Section 6.5 is on dilations, and our goal for this section is to identify if a dilation results in an enlargement or a reduction. And they basically mean what they sound like. Enlargement means it's getting bigger, and a reduction means that it's getting smaller. So a dilation is basically taking the same shape and just making it bigger. So on this image, or this picture that we have below, we are going to be identifying if it's in a reduction or an enlargement, and we're going to find the scale factor. So this first one, we're going to go ahead and label everything. So this P, this one is going to be our pre-image because it doesn't have any of those prime marks. And P prime is going to be our image. And remember, we go from the pre-image, we go to the image. So we went from this P to P prime, and we are looking at that, and if it got smaller, we would say it's a reduction, but in this case, it got larger. So this one is indeed going to be an enlargement. So we need to go ahead and find the scale factor. So when you're finding the scale factor, that is equal to the measurement of the image over the measure of the pre-image. So for this one, they give us the measurement from point C. So the measurement from C all the way to P prime, they give us is 12. So our scale factor in this one is going to start with 12. And then if we look from C to point P, they give us the measurement of 8. So our scale factor is going to be 12 over 8. When you're writing your scale factor, you're going to leave it as a fraction. So leave as a fraction. And then you're also going to have to simplify it. So both of these numbers are divisible by 4, so we're going to go ahead and divide those out. So our final scale factor is going to be 3 over 2. Okay. So use this information and try to complete part B. You are going to be identifying what the scale factor is and if it's an enlargement or a reduction. So go ahead and do that, and then hit play once you have your answers. So for this one, our pre-image is the bigger one, and then our image is the smaller one. So we went from the bigger to the smaller. Excuse me. So this one is a reduction and got smaller. So to find our scale factor, that's what SF stands for. So if you want to abbreviate it, that's okay. Remember, our pre-image goes on top. So the distance from this point C to P prime, they give us is 18. And then from C to our pre-image is 30. So, if you simplified this all the way, we could divide both numbers by 6, and we would get 3 over 5. So one thing I want to point out, if we have a reduction, your scale factor is less than 1. So you'll notice 3/5 is less than 1. If we have an enlargement, this means our scale factor is going to be greater than 1. and 3 over 2 is bigger than 1. So when our scale factor is bigger than 1, it's going to result in a larger image. Okay. So moving on to example 2. This one we are going to graph on a coordinate grid, and then we are going to do a composition. So go ahead and plot the points for the triangle. And remember, don't forget to label them. That is important. If you don't do that, you will miss out on points on a quiz or a test. So there we are. We've got our graph. And we are going to complete the composition. So I'd like you to try the translation part on your own. You should know how to do that. So pause the video and go ahead and complete that translation. So when you're looking at this, we have x plus 5. And remember, x is positive to the right. So we know we're going right 5. And then we have y plus 1. And y is positive going up. So we're going to go up 1. 1, 2, 3, 4, 5, 1. And don't forget, when we label these ones are our prime marks. So A, B, C, all prime. There we go. So if your triangle isn't in the right spot, make sure you fix that before you move on to the next part. So the second part of our composition is a dilation centered at the origin with a scale factor of 2. So what we're going to do first is we're going to write down the coordinate points of our prime marks. So A prime was at 1, 2. B prime was at 3, 3. And C prime was at 3, 2. So what we're going to do with those is we are going to dilate this with a scale factor of 2, which means that we're making our image 2 times as larger. And we are centering this at the origin. So all we're going to do is we're going to multiply every coordinate point by 2. And we are multiplying both the x and the y's by 2. So this is going to be 2, 4 for A double prime. And then we do the same thing for the rest of our coordinate points. So you can go ahead and plot those on your grid. And once you're done, you can hit play to check it again to make sure that you got it correct. For B double prime, that one should have been at 6, 6. And for C double prime, you should have got 6, 4 for that one. And you'll notice this triangle is twice as big as the previous triangles because it had a scale factor of 2. So it's now the height is 2 instead of 1, and then the length of the base is 4 instead of 2. So make sure those are in the correct spot, and then once you're ready to move on, you can hit play again. We are going to skip example 4, but we're going to go ahead and do example 3. And the vertices of triangle RST are 1, 2, 2, 1, and then 2, 2. We are going to find the coordinate points of the dilation if it has a scale factor, again, of 2. So you do the same thing for this one. You go ahead and you start with the original coordinate points, and then you multiply it by the scale factor to find the new coordinate points. So again, we are just multiplying everything by 2. So go ahead, pause the video, and complete that, and then you can check your answers when you're done. So for R prime, you should have had 2, 4. S prime, you should have had 4, 2. And then T prime, you should have had 4, 4. Excuse me. So you do get you are able to get the coordinate points without having to graph the image as well. On the test, there are going to be questions, both like the one where you have to graph and then also where you just have the coordinate points given to you. So it is important that you know how to do both. All right. For example 5, again, you are going to identify the scale factor, tell whether it's a reduction or enlargement, and you're going to find the value of x. So let's start with number 3. We went from the blue to the red image. So if that one got bigger, we're going to put an enlargement. If it got smaller, we're going to put a reduction. So this one is for sure an enlargement. And we need to identify the scale factor. And remember, with your scale factor, you put the image. Let me make sure I'm saying that right. Yeah, you put the image above the pre-image. Sorry. So our image length in this example from point C to P prime was 14. And then our pre-image length from C to P was 6. Both of these are divisible by 2. So don't forget, you do need to simplify your fractions, and we would get a scale factor of 7/3. And then the last thing we needed to do was find the value of x. So we know the entire length of this segment is 14. So our equation is going to start with 14 equals, and it is equal to this segment, 6, plus this segment, x. So we know 14 is equal to 6 plus x. Excuse me. Once you set up that equation, you are good to go to solve for x. And there you are. So why don't you pause the video, try number 4 and 5, and then once you have those answers, press play to check your answers. All right, so starting with number 4, this one went from P to P prime. This one got smaller, so this one was a reduction. And looking for the scale factor, our image in this one was x. So we need to figure out what that length is before we can write our scale factor. So we know the entire length is 15, and that would be equal to 9 plus x. Subtract 9 on both sides, and we would get 6 equals x. So we know that is 6. So the length of our image for our scale factor on top is going to be 6 over, and that was from C to our image. Now we need to find the length from C to our pre-image, which is 15. And both of these are divisible by 3. So your final scale factor should have been 2/5 for this one. So if any of that you had the wrong answers, make sure you go ahead and fix it before you move on to the next problem. All right, and for example 5, we went from the P to P prime. So this one got bigger. So this one would be an enlargement. And then we're looking for our scale factor. This one, they don't give us the lengths from point C, but they do give us lengths on the side of the triangles. So this side, RP, lines up with R prime, P prime. So we're going to take the length on our image, which is 12, and we're going to put that over the length on our pre-image, 8. And this will give us our scale factor, and both of these are divisible by 4. So your final scale factor that you should have had was 3/2. Excuse me. And then once you have that scale factor, we need to figure out what x equals. So now the scale factor, what that tells us is what we are going to take and multiply our pre-image by. So we multiplied this by 3/2 to get to our image. Also, to get back to our pre-image, we would divide that number by our scale factor. So to get x from 15, we're going to take 15 divided by 3/2, and that is going to be equal to x. Another way you could set up this problem is by taking x times 3/2, and that would be equal to 15. So you could set up either of these. You'll get the same answer. Remember, when you're dividing by a fraction, you keep the first number, you change the sign to multiplication, and then you flip the second fraction. So this would become 2/3. And then once you have this, you just multiply. So you would take 15 times 2, which would be 30, and 1 times 3 is 3. And once you're there, you just simplify. 30 divided by 3 is 10. If you set it up the other way, to get rid of the fraction, you multiply by the reciprocal, 2/3. And you'll notice it's the same problem as what we were just working on. So these simplify to just x. We would get 30/3. And again, we would get x equals 10. So now that you have that all done, you should be good to go to complete the homework. If you have any questions,